Welcome to another high school chemistry video. Today we're going to talk about what is matter. So our objective is to know what matter is, be able to evaluate states of matter based on their observed physical state and their molecular motion and spacing. We're going to talk a little bit about changes in matter and whether that is physical or chemical changes. So states of matter. The three main states of matter are the solid, which holds its shape and doesn't take the shape of the container, the liquid, which takes the shape of the container but not the volume of that container, a gas, which takes on the shape and volume of a container. So thinking about those in terms of molecular motion, believe it or not, all matter, everything, is moving all the time. So even solids are moving, they're just vibrating a little bit. So the solids are vibrating, the liquids are vibrating a little bit more and moving around a little bit more, and then your gases are crazy and vibrating everywhere. So you can change phases, going from a solid to a liquid to a gas, or a gas back to a solid. Gas back to solid is called condensing or deposition. Deposition is actually a better term for this. That's why it's there, but you will see both used at times. Gas going to a liquid is condensing or condensation. Liquid going to a gas is evaporating. From a solid straight to a gas is subliming or sublimation. There's actually some that call gas to a solid desublimation. I prefer deposition as a term. Solid to liquid, liquid to solid are some of the most common terms for us. Freezing and melting. It's that simple. So when we look at the organization of matter, matter can be organized into mixtures or pure substances. The mixtures are either homogeneous or heterogeneous. We're going to talk about those when we talk about solutions, but homogeneous meaning a pure mixture where you really can't tell the difference between them, and heterogeneous, you could see the differences between those things. Pure substances are broken down further into elements and compounds, and from there, elements are broken into atoms, nucleus, electrons, protons, neutrons. Properties of matter. There are extensive properties, which depends on how much matter you have present, and intensive properties that don't depend on how much matter you have present. So those are kind of intensive or inherent to the element or the matter itself. So an extensive property is something like volume. How much you have determines how much volume you have. Mass. The more stuff you have, the more stuff you have, right? Yeah, okay, so that's mass, right? And energy content. So think calories. The more you eat, the more calories you consume. Intensive properties are things that are inherent to it. Melting point. Doesn't matter how much ice I have, it all melts at the same temperature. Depends on how long it takes to melt, but the temperature is still the same. Boiling point, same idea. Doesn't matter how much water I have, it will boil at the same temperature, assuming the external pressure is the same. And density. How dense something is, its mass per unit volume, and so you'll always have the same density given the same temperature and the same things like that, no matter how much you have. The density of water at room temperature is the same whether I have a drop of water or whether I have 800 million gallons of water. Matter changes. So the law of conservation of mass states that no matter how much matter changes, it is conserved. That mass is conserved when matter changes. So there are exceptions to this law that are in nuclear chemistry, but we're not going to talk about those right now. For the most part, mass is going to be conserved. So this can occur whether there's a physical or a chemical change. No matter what, if it's a chemical reaction, the total mass when you start and the total mass when you end should stay the same. In physical changes, only the physical form or phase changes. So a phase change, shape change, something like that. In a chemical change, there's a change in the molecules and how they're rearranged. So things get rearranged and put back together in a different way and end up with a new molecule or new compounds. So let's talk about physical or chemical changes. I want you to answer whether each of these is a physical or chemical change as we go, and then I'll tell you what I think. First one is grinding chalk into powder. So this is a physical change. The chalk is still chalk. It's just a stick of chalk or powdered chalk, or a rock of chalk, or powdered chalk. It's still calcium carbonate. It's still chalk. Baking soda mixing with vinegar and bubbling. So some of the keys here are that it's bubbling, right? That bubbling means there's a gas being produced. It's not dissolved. Believe it or not, this is a chemical change that's occurring. You get a froth, you get bubbles, you get carbon dioxide produced. Hydrochloric acid mixed with magnesium forming hydrogen gas. Chemical or physical change. So the key here is that it says it forms hydrogen gas. It makes something new. So this is a chemical change. Mixing iodine with starch in water and the color changing. So believe it or not, color changing can be physical or chemical. But I'm going to tell you this one is a chemical change. It's a chemical change because what happens is the iodine reacts with a starch molecule and forms a weird complex that turns purple. It's such a cool reaction. Hopefully we'll get to see that later in the year. Ice melting. A physical change. It goes from solid water, which is ice, to liquid water, which we call water. A candle burning. The process of burning is a chemical change. You're actually consuming the wax. It's reacting with the oxygen in the air to form new compounds, carbon dioxide, water, and sometimes a few other small molecules and things like that. But the process of burning itself is always a chemical change. Bending a spoon with your mind. It's a physical change. You're just changing the shape of something. You're not actually changing the molecular structure of that. Iron rusting. Initially, it feels physical because you look at it and you're like, oh yeah, I can see that. So it's nah. Rust is a new compound. It's oxygen reacting with iron to form iron oxide, and that's what rust is. So this is a chemical change. Boiling water. Again, it's just a phase change. It is a physical change. Baking a cake. This one's depends on which part of the baking you're thinking of. There's actually physical processes going on. There's evaporation. There's chemical processes. There's denaturing of proteins. There's recombination of starches. If you put baking powder or baking soda and an acid in there, you're getting an acid-base reaction producing a leavening agent, which produces CO2, which, yeah, it's either one. Depends on what you're talking about. Dry ice sublimating. If you'll remember, sublimating, it's a physical change. Sublimation is a phase change, going from a solid to a gas without going through liquid in the middle. Dry ice is carbon dioxide. It is just a physical change. Raining. A physical change. It's condensation. It is gaseous water forming into droplets and falling to the ground as liquid water. It's physical. Your body producing proteins. Your physical body producing proteins. It's chemical. Most of the processes in your body, your physical body, are chemical processes because it's reactions forming new compounds, new molecules, new everything all the time. Making tea. It's a physical change. Making tea is physical. You're just extracting things from the tea into the water to make the tea. Even if you're talking about adding the sugar, it's just dissolving. The sugar is still sugar, the water is still water. Dissolving salt. Again, dissolving is a physical process. There are chemical aspects to this process, but it is still a physical process. A blacksmith forging metal. Mostly physical. Unless you're talking about the forge and some of the other reactions, it is mostly a physical process. HGS, black mercury sulfide, transforming to form red mercury sulfide. This is a crystal structure change, which is a phase change, which means it's a physical process.